Have you ever stood next to a giant mining truck and felt completely dwarfed? Or watched a colossal tunnel boring machine disappear into the earth and wondered, how on earth did they even build that thing? These mega machines are the unsung heroes of our modern world, shaping our cities and powering our industries. But how are these titans of steel actually constructed? Today, we're going deep inside the world of heavy engineering to uncover the secrets behind their creation. It's a story of incredible precision, immense power, and brilliant human ingenuity. So, buckle up, because this is going to be epic. The journey of a mega machine begins long before the first piece of metal is cut. It starts as a digital dream, a complex 3D model inside a computer. Teams of engineers spend thousands of hours designing every single component, from the smallest bolt to the largest structural frame. They use sophisticated software to run simulations, testing for stress, durability, and efficiency under the most extreme conditions imaginable. They have to think about everything: the intense heat of a steel mill, the crushing pressure deep underground, or the relentless, repetitive motion of lifting thousands of tons. Every calculation must be perfect, because in the world of mega machines, there is absolutely no room for error. A tiny miscalculation could lead to catastrophic failure. Once the design is finalized and approved, the manufacturing process begins, and it's unlike any other. You can't just order a 400-ton truck chassis from a catalog. These components are often so large they have to be forged and fabricated in specialized facilities. We're talking about foundries where molten metal, heated to thousands of degrees, is poured into massive molds to create engine blocks or gear components. Imagine a single gear that's taller than a person. Then, these raw parts move to enormous machining centers. CNC machines, some the size of a small house, meticulously carve, drill, and grind the metal with microscopic precision, ensuring every piece fits together perfectly. It's a fascinating dance between brute force and delicate accuracy. Now for the truly awe-inspiring part: assembly. Since these machines are too big to be built and shipped in one piece, they are often constructed in massive, modular sections. Think of it like a giant, ultra-complex Lego set. These modules, each weighing many tons, are manufactured and then transported to the final assembly site. This could be a vast factory floor or even directly at the location where the machine will be put to work, like a mine or a construction project. Giant overhead cranes, themselves marvels of engineering, lift and position these huge sections with incredible precision. Highly skilled teams of technicians and welders then get to work, fastening thousands of high-tensile bolts and laying down kilometers of welding beads to join the modules together. It's a symphony of coordinated effort, where every team member plays a crucial role. But it's not just about the steel skeleton. The nervous system of these giants is just as complex. Technicians carefully install the hydraulic systems, a network of pipes and pumps that act as the machine's muscles, capable of generating immense lifting and digging forces. They also route miles of electrical wiring, connecting the central control unit, the brain, to hundreds of sensors, motors, and actuators. This electronic architecture allows a single operator, sitting comfortably in a high-tech cabin, to control a multi-million-dollar behemoth with just a few joysticks and a touchscreen. The level of technology packed into these machines is simply staggering. Before a mega machine is cleared for duty, it must undergo a battery of rigorous tests. This isn't just a quick spin around the block. Engineers test every single function, from the swing of a giant excavator arm to the braking power of a fully loaded dump truck. They push the machine to its operational limits and beyond, ensuring it can handle the toughest jobs safely and reliably. This quality control phase is non-negotiable. The safety of the operators and the efficiency of the entire project depend on the machine performing flawlessly from day one. Only after passing every single check is the machine officially commissioned and handed over, ready to start its working life. Let's take a real-world example: the bucket wheel excavator. These are the largest land vehicles on Earth. Their construction is a monumental undertaking that can take years. The main components, like the massive bucket wheel itself and the long conveyor booms, are built in sections and shipped to the mining site. Assembly requires some of the world's largest mobile cranes. Piece by piece, the giant is assembled on site, a process that can take several months. Welders work around the clock to join the massive steel plates, and electricians install a power system capable of powering a small town. When it finally roars to life, it can move over 240,000 cubic meters of earth per day. It's a true land-based battleship. Another amazing example is the tunnel boring machine, or TBM. These are essentially mobile factories that dig tunnels and install the concrete lining simultaneously. A TBM is custom-built for a specific project because its diameter must match the tunnel's design perfectly. The massive cutter head, studded with rotating discs, is assembled and tested at the factory before being disassembled for transport. At the launch site, a massive pit is excavated and the TBM is reassembled inside it. Then, using powerful hydraulic grippers, it pushes itself forward, carving through rock and soil while its automated systems install the tunnel segments behind it. It's an incredible feat of engineering that allows us to build subways and tunnels under mountains and cities. So, from a digital blueprint to a fully operational titan of industry, the construction of a mega machine is a testament to human ambition and collaboration. It combines cutting-edge digital design, powerful manufacturing processes, and the skilled hands of thousands of dedicated professionals. These machines don't just move earth or lift heavy loads. They are the very tools we use to build our future, pushing the boundaries of what is possible. They are a powerful reminder that with a clear vision, meticulous planning, and a lot of hard work, we can build almost anything we can imagine. Thank you so much for joining us on this deep dive into the world of heavy engineering. I hope you found it as fascinating as I do. If you enjoyed this video and want to see more content about incredible feats of engineering and technology, please hit that like button and subscribe to the channel. Don't forget to ring the bell so you won't miss our next adventure. Let us know in the comments which mega machine you'd like us to feature next. Thanks for watching, and we'll see you in the next one.